In this video, we're going to explore how to handle missing data in a data set. This is very important for data mining with machine learning because the reality is, this is where we spend most of our work. We get a data set, maybe it's not perfectly clean. Maybe we said give your user ID and some people gave an email address, some people gave an employee number, some people gave a student number, something like that. And we have to clean up the data. So this is a big task, but it's one that Python does very well. So first of all, I've already put in the imports for NumPy and pandas. And now I've created a data set with some missing data. You see the word none here in a few cases. And in pd.NaN. So none effectively means no data there, and then NaN means not a number. You see, it may be a little tricky to read right now, but we'll make this more readable. What we can see is we have a list within a list, or a multi-dimensional list, or multi-dimensional array, if you will. So we start with open square bracket and close square bracket, and then within that we have a set of 5 open and close square brackets, all of which have an integer or no data, another integer, some kind of floating point data, a word, and then some kind of floating point data again. Let's take a look at what we've created here. Not surprisingly, it comes out just fine. Let's take a look at the type. And type is a list. Not very obvious here, but it is a list within a list. Well, one of the nice things about this data structure is it's easy to create a data frame out of a list within a list. So let's try that. So have a look at how I did this. I used PD, so pandas, and then DataFrame. And inside of the DataFrame, I pass in our sample data two-dimensional list. Now I give it an index, and notice that the index is talking about each row. Now if you don't recognize these are genus names, where the common name is the name that, that we typically refer to in English of this plant. So Cercis is the genus for redbud, Prunus for cherry, Petunia for petunia, Magnolia for magnolia, and Acer for maple. Truth is, that's not really a good index on its own because there are multiple species per genus, so we probably want something else if this were real data, but for our purposes, this will be just fine. Now notice I also provided a columns argument. So index equals, and then a list of indices, and then columns equals, and then the columns, and hopefully this will help to describe the data that we have. So the minimum height of an adult Cercis canadensis eastern redbud, the maximum height, flower length, average price, common name, and then a kind of like a sustainability metric. Now we can look at some information about our data frame. And you see that it lists out each of our columns, and it also gives us a data type that it has figured out for the column. So float would mean it has a decimal in it, int means no decimal, and then object is typically anything else, most often a string. Now there's something really neat that we can do, which is a Boolean mask, where in this case we have 5 rows, and we can pass in a series of Booleans to say, I want only these rows. We pass them in the order of the rows that we wish to receive. So for that we'll say smaller df. Now careful here because we need a couple of square bracket pairs. One to say we're selecting from the sample df. As you see right here, we're selecting something. Within that, we want to say we're providing it a list of what we're selecting. Let's say false, true, true, false, false. And then we print out smaller df and take a look at what we selected, Prunus and Petunia. And where do those fall in our grander data frame? Well, they're right here. So false, true, true, false, false. We come down here and we see that sure enough that matches false, true, true, false, false. Now where this gets powerful is not that we're always typing in true, false, like so into a list, but many times we can compute this based on something like emptiness. Note that I can simply say pd, so pandas.isna, call that function, pass in the sample df, and then it gives me a true or a false based on which has valid data and which is null. I can narrow this down to a specific column if I wish as well, just by attaching that column after the sample df. You see, now it gives me false, false, true, 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 just like so, so it's a mask on only one column. Well, the neat thing is I can use this mask on one column to select the rows that match, in this case, say, empty data. Simply combine these two lines together, our selection line and then our decision line up above, and we see that this returns to us the two rows that have nothing for the flower length. Now we can reverse this as well. We might want to look at this to say, okay, maybe flower length is a feature that we want to consider, and so we want to take a look at the rows that have an empty value for that to determine if we want to discard them or if we maybe want to plug a different value in there for that feature. We can look the other way as well. We can say, show me only the rows with valid data, and then we'll know, okay, if we drop the invalid data, what's going to be left. So simply take the same thing, and instead of saying is in A, I'm going to say not in A. And now you see we only get the rows that have a valid flower length. Once we know where we have empty values, we can take a couple of approaches. One is we could fill them in with 0, or we could fill them in with some other number like the mean of the entire column, or we can simply drop them. Let's take a look. We know that flower length has a couple of empty values, so that's an easy one to fill in. That may not be a very important column, or maybe it is, but nonetheless, let's try this. You see, sure enough, it filled in those last two values with a 0. Sometimes that's good. Sometimes we want another approach. Maybe we don't want to set off or skew the data too much, so we'll fill something in with mean. So in this case, let's look at sustainability, and you see that's still NaN for our Cercis canadensis eastern redbud. And of course, there could be more rows, so let's just do a fill in A. But this time it's going to be similar, except it's going to be filling with the mean instead of the 0. So take a look at our results here. You see that where sustainability was NaN, now sustainability is 4.125, which if you eyeball it, yeah, that looks about like the mean of the other values. So we have a value here that's not necessarily going to skew everything else. Let's look a little closer at the statement that I ran in both cases and do a bit of compare and contrast. First of all, you notice on flower length I use dot notation here where to access the column, where down here I use the square brackets and the column name is a string. No big difference. That's really dealer's choice there, fielder's choice. Use whichever you want. As long as there aren't spaces or special characters, you can use the dot notation. Otherwise, this is fine. We have that to the left of the equal sign in both cases, which means we're doing some activity on the right, taking the result of that and assigning that to what is on the left. And what is on the left but our column? So we're effectively assigning a new value or an updated value to our column, whether it's flower length or sustainability. After that, we're accessing this very same column. And in the first one, we're saying fill in A with 0, and sure enough, that gives us our two zeros. In the last one, we're saying fill in A, but instead of plugging in 0, we're plugging in the mean of the sustainability column. So it's kind of interesting here. You see the sustainability column is referenced a total of 3 different times. The third time is to get that mean. Our data looks a whole lot better now, although we do still have a couple of invalid values in average price and min height. And of course, the question now is, are those invalid values going to affect a feature if we're doing data modeling? If so, maybe we want to do some further cleaning. If not, we can leave them alone. There is one nuclear option as well, and that is drop NA, and that effectively drops anything that is empty. You see here that takes us down to about 3 rows where we originally have 5, and you notice the ones that are missing are petunia with nothing in the min height and average price, prunus with nothing in the average price. And so this leaves us only complete data. So we want to be careful, as I mentioned. We don't want to get rid of too much data because the rule of thumb is each unique feature requires about 50 columns or more to come up with a good regression model. So we don't want to be too aggressive about dropping, and that's why I say focus on just the columns you think that you might use as features. So that's a look at cleaning up our data in Python with NumPy and Pandas. I hope you found this video helpful, and I look forward to reading your feedback. Thank you.